Welcome, ladies and gentlemen, to today's webinar about punching shear design of wall ends, wall corners and columns in the new additional module to RFEM RF Punch Pro. My name is Wieland Götzler, and in this session I am supported by my colleague Alexander Meyerhofer and Moritz Bertram, who will show you a live demo with the new module. First of all, we want to take a look at the contents of today's webinar. At the beginning, I want to show you a short presentation of the new features of the module RF Punch Pro, and followed by that is a live demo about punching shear design of wall ends, wall corners and columns, according to Eurocode 2 by my colleague Moritz. Let's take a look at the features in RF Punch Pro. As the old module RF Punch, the design is performed according to Eurocode 2 in RFEM. As you can see in orange color, there are some new features in the new module RF Punch Pro. Now the design is also possible not only for columns, it's also possible for wall ends and wall corners. You can locate a large column head and automatic detection of punching nodes and also openings are automatic considered in RFEM. Now I want to change my screen to my colleague Moritz, who will show you a live demo about the new module.
Thanks, Wieland, for the introduction. We have two new main features in RF Punch Pro. One is the design for wall ends and wall corners, and the other one is the punching shear design at a column considering an enlarged column head. I'll explain the design procedure using a simple 3D model which you see on the screen, and we will do punching shear design at the wall end, at the wall corner, and later on design of with and without an enlarged column head at this column in node number 6. I start the module using the navigator, RF Punch Pro, and go right to table number 1.1, general data. First thing I'm doing is renaming this design case via file, rename case, and the description is wall corner. Okay, now I want to pick the nodes that I want to design. In this case, I pick node number 5. Oh, sorry. Okay, and for the design, I'm going to use the result combination number 1. Which is an envelope of the load combinations 1 through 5. Last thing I have to do in this table is selecting the code I want to use. In this case, it's the Eurocode 2 with the national annex for Germany, DIN. Next, I switch to the table 1.2 materials and surfaces. Here I have the possibility to change the materials. The materials are taken over from RFEM, but I always have the possibility to change them during my work. Also, I can select the reinforcing steel. We will stay with the one that's pre-selected. The third option I can change in this table is this surface thickness, which is being left at 28 centimeters. The next table deals with the additional openings. Openings in the RFEM model are usually recognized and used for the design automatically. But if I have smaller openings that are not relevant for the design of the longitudinal reinforcement, I can take those openings into account using this table, because these smaller openings can still influence the basic control parameter for the punching shear design, which is very important. So if I want to enter an additional opening, I use this reference surface number 1, which is my upper slab. The reference node is the node which is my wall corner. Here you see this green dot. I have to select it, and now this local coordinate system number is the reference for my additional opening. The location, it's the opening is located at 0.5 by 0.5 meters in X and Y direction. The shape is rectangular and the dimensions are 0.25 by 0.25 meters. Now this opening is shown in this graphics window down here. I can also enter an optional rotation, but since we are not going to use this opening, I'm just going to highlight this line, right click and delete it. And now I'm going to the next table, which deals with longitudinal reinforcement. I can't enter any reinforcement content here, but I have to keep in mind that I can change the concrete cover for determining the effective depth of the calculation, in the calculation. I'm gonna do that later on, so now I'm gonna skip to nodes of punching shear and the details for the punching shear design at node number 5. The punching shape is automatically recognized. In this case, it's the wall corner. And also the position of this punching node, this design node, is automatically recognized. In this case, it's in the middle of the slab. While this was not possible in the old punch module, there it was necessary to manually select the position. So this is also a smaller new feature. Then we have the column punching shear reinforcement. The vertical punching shear reinforcement is pre-selected, and if the longitudinal reinforcement can't be increased anymore to meet the requirements, then punching shear reinforcement will be necessary. You also have the option to select no punching shear reinforcement, inclined punching shear reinforcement, and the half-an HDB punching shear reinforcement elements. As soon as we select this option HDB, the calculation button vanishes and there's a new button HDB, which links to the half-an HDB program. Loading and geometry can be exported to this program and the design can be done externally. But this requires the download and installation of a current version of the HDB program beforehand. We'll stick with the vertical punching shear reinforcement. The wall thickness is automatically recognized. It's for both walls 0.25 meters. And which this can be changed up in the table or down in the details. Also, I've already mentioned it, the position can be selected, although it's correctly preset. Then we have the possibility to use select the structural element that's to be designed. One possibility is the normal slab, and the other one is the foundation slab. I'm going to go briefly into the foundation slab at the end of the presentation. The used punching load is, there's a distinction drawn between a smoothed and an unsmoothed shear force over the critical parameter. The unsmoothed option is the default one, and if you have a column, there's a third possibility for the used punching load. Then you can take the nodal support load or the column of normal force as a direct load from RFEM. Now we are going to stick with the unsmoothed version. For this, section is created at the critical parameter. It's the red one in the picture. For the determination of the shear force. For that, the internal forces are taken from RFEM and they are integrated into this section. We are now going to do the design for the unsmoothed punching shear and compare that to the smooth punching shear later on. The further adjustments could be the direction of the punching force, although this is recognized automatically, but can be changed. And the consideration of minimum bending moments, the definition of manual definition of the parameters, and the definition of a longitudinal reinforcement for the design. We're going to do that later, so I'm gonna leave that here and do a calculation. Okay, now we get a design criterion for this design with a unsmoothed approach of 0.72, and are going to compare this to a smoothed approach now. For that, I copy this case and call it wall corner smoothed. Okay, and switches to the second case. I just skipped to the table 1.5 nodes of punching shear and switched to the smooth shear force over the critical parameter. If I check that, I get a new line, load increasing factor beta. Here you can choose if you want to determine beta with a full plastic shear distribution, which is the default setting. Alternatively, you could use the constant factors according to figure 6.21n according to EC2, which is 1.1 for the middle of the slab, 1.4 for the edge, and 1.5 for the corner. But we keep the full plastic shear distribution and do a calculation. The design criterion for the approach with a smooth shear force is 0.8, which is actually similar to the approach with the unsmoothed shear force, but still there's a little difference. So now I'm going to switch to the graphics in the RFEM program. You see in the for the shear force at the critical parameter, I get mean value at the critical parameter of 77.92 kilonewtons per meter in case 2 with a smooth shear force, and if I switch to case 1, unsmooth, we get a maximum value at the critical parameter of 87.93 kilonewtons per meter. Now I return to the module using this button RF Punch Pro, and want to go a little more into detail for the results. So we have for case 1 unsmoothed shear force. We have the we use the maximum shear force of 87.95 kilonewtons per meter multiplied with the length of the basic control parameter, and which gives us an applied shear force of 132.33 kilonewtons, and out of that we get the applied maximum shear stress of 359 kilonewtons per square meter. Beta is 1.0 because we are in this case using the maximum shear force in the parameter. In case 2, we are using the mean value at the critical parameter of 77.92 kilonewtons per meter, again multiplied with the length of the basic control parameter. We get a governing punching load of 117.24 kilonewtons, and out of that, using beta 1.25, which is calculated by the program, we get a maximum shear stress of 396 kilonewtons per square meter. Okay, we get similar results, I already said that, and also we get a comment in the last column. The comment number 51 is: the design shear resistance of the slab without shear reinforcement is sufficient. There are no further checks necessary. So we are so far done with the wall corner design, and now I will have a look at the wall end design. For that I switch to case 1 again and rename that case and call it wall corner and wall end. Okay. Now I have to select this additional node, number 9, at the wall end, and yeah, I'm going to use all these settings I've used before and switch to 1.5 nodes of punching shear again. Now we always see which node we are right now working on using the graphics window. Now it's node number 5. We've already done that. Node number 9 is at the wall end, and now we can have a look at that. we are going to use the unsmoothed shear force at the critical parameter, and we want to increase the longitudinal reinforcement automatically for reaching a sufficient shear resistance. So we are going to start the calculation. Now you see node number 9 is at a design criterion of 1.0, which leads me to the conclusion that something has been done to reach this limit, to limit it to 1.0. And looking into table 2.2 required punching shear reinforcement, I see that for node number 9 I have a reinforcement area of 25.66 square centimeters per meter in both directions on the top surface of the slab. So this has been increased by quite a bit, but actually I don't want to have such a big reinforcement area because it's not very handy. So I go into the nodes of punching shear again and set a longitudinal reinforcement cross-section. I do the check for define cross-section, and now I can enter cross-section for the longitudinal reinforcement. In this case we want to have a diameter 12 in 10 centimeters, so that's 11.31 square centimeters per meter in both directions. And now we have a fixed cross-section, so it can't be increased anymore. So if that's not sufficient, I'll get some vertical punching shear reinforcement. Since I've adjusted this, or since I've entered this cross-section with a diameter 12, I have to have a short look into the longitudinal reinforcement table because I need to adjust my concrete cover. In this case to 3.1 for the first direction and 4.3 for the second. You see something has changed in this graphics. It's just for calculating the correct effective depth. So now the input is done and I can do a calculation with a preset longitudinal reinforcement. Now the design shear resistance with only the longitudinal reinforcement is at 1.31, so it's not sufficient, and the program has to add some vertical shear reinforcement. We have 3 more design values, design ratios in this design. The first one is for the maximum shear resistance limited by the concrete struts. And the second one is the shear resistance limited by shear reinforcement. And the last one for the shear resistance at the outermost control parameters. These last designs are done so the requirements are just met and we get a design criterion of 1.0. If we look into 2.2 required punching shear reinforcement now, we have our longitudinal reinforcement of 11.31 square centimeters per meter in both directions, and the vertical shear reinforcement at the first and the second parameter. If I click on that one, I get a picture of my first parameter where I have a shear reinforcement of 5.56 square centimeters at a distance of 12.2 centimeters from the face of the wall. And at the second parameter I have 3.11 square centimeters at 28.2 centimeters from the wall face. Now we can also see these results in the graphics of RFEM. So now the first thing we see is the shear force at the critical parameter for the wall corner and the wall end. But we want to see first the longitudinal reinforcement in both directions and the punching shear reinforcement at these two parameters I've already shown you within the module. Also we can see the design ratios in here. First one for the resistance without the reinforcement, we see 1.31, that's too big. So the second I want to show you is the design shear resistance with reinforcement of 1.0, and the third one is the maximum shear resistance for the concrete struts, and the last is the design ratio for the outer parameter. So this is the furthest we have to do a design for the punching shear from the wall face. All these graphics can also be printed into the printout report, as you know from RFEM, using the print graphic button up here. So you could just print them one by one, or you can also do a mass print of all these graphics you want to have in your printout report. So I go on mass print results, and now I can select all these pictures I want to have, the design ratios and the punching loads. So that's 6 graphics, or as many as you want. But I'm not going to do that now. I'm going to cancel the command and go on with the design. The next thing I want to tell you is the design at the column. So I make a new case number 3 for the enlarged column head. Okay, and I select the node number 6, and on top of the column I also select the result combination number 1 for my design. I switch to 1.5 directly and see that there's again the automatic recognition of the rectangular punching shape. I can also see that in the window with the critical parameter. Also, the position in the middle of the slab is recognized. We leave the default settings for now without any longitudinal reinforcement and with the automatic determination of beta. and do a calculation, we see that there's going to be longitudinal reinforcement required. I think that's too much, and for that I'm going to enter an enlarged column head for the design, so I get a better result. So we don't want to have any longitudinal reinforcement. We've already seen that for the wall end, but new in RF Punch Pro is the enlarged column head, which I can check using this line. And now, as soon as I check this box, I get a few more options for the enlarged column head. We are using the stair shape for the column head with a distance, and I can change the distance of the column face to the edge of the column head. Now it's at 30 centimeters. I can change it as I want to, and the critical parameter always gets larger as I increase these distances. I go back to the 30 by 30, but I'll adjust the height of the column head. The height is just the height below the slab, so the slab is not included. So now we are 30 centimeters below the slab, and as you see now, this is a dashed line. This means the critical parameter of the punching of the column through the column head is outside the punching shear, outside the critical parameter of the column head through the slab. So this punching shear wouldn't make any sense, and it's not necessary. If I go a little smaller with my height, I get this this parameter inside the larger parameter of the column head, and thus I have to do like 2 punching shear designs in one calculation. So I'll stick with that and do the calculation. And now I see I get a design shear resistance for punching of the column head through the slab of 0.72 and a design criterion of 0.94 for the punching of the column through the column head. I can again show this within the graphics in RFEM. Now this is my column cross section, and this is my column head, and I can see the design ratios for both. The red one is the punching of the column through the column head, and the blue one is the punching of the column head through the slab, with these values of 0.94 and 0.72 in that we've already seen. Also, there's an extension of the result navigator now with where I can show the results for both slab and enlarged column head combined, and each one for itself. So much for the new features in the module. For completion, I want to give you a hint for a punching shear design of foundation slabs. And because before we had a regular slab, now we do the same thing for the bottom slab, which is bedded continuously. And now I make a new case, foundation slab. Result combination number 1. I pick the nodes at the bottom of the wall we've handled before. Okay. And switch to nodes of punching shear. Again, the punching shape is recognized by the program. And also, since we have a continuously bedded slab now, the program recognizes that this has to be a foundation. The settings are being kept at default, and I start the calculation. And now this is actually the important thing for the foundation design. The distance to the loaded area, and thus the length of the basic control parameter, is calculated iteratively. And yeah, I can also see this in the graphics window, where this is a little smaller than before in the regular slab. Okay, so much for the presentation of RF Punch Pro with its new features. I hope you could get a lot of new informations and new input, and thank you for your attention. Wieland, anything else from you?
So, thank you very much for this presentation, Moritz. For me as a steel guy, it was quite interesting. Maybe I should get some information from our homepage about this concrete structures. You can check this also if you just look at dlubal.com. You can select the solutions, for example, for products, RFEM or RSTAR modules, and there you will find the reinforced concrete structures with all the concrete modules we offer to you, like this new one, RF Punch Pro add-on module for RFEM. You can, of course, download the free trial version, 30-day free trial version with all the additional modules, or you can just call us if you have some questions, send us an email, and at the webpage you will also find additional informations like trade fairs and conferences where you can get in touch with us in person. And like over there, we will be there in Italy or United States quite soon. And on the bottom, you can also check this link to youtube.com with our presentation over there, and there you will find additional webinars about connections, about dynamics, of course the concrete webinar of today, and hope you get all the information you need. And therefore I would be very satisfied to see you up in the next webinar or to receive an email from you. And again, I would like to thank you for your attention, as well as Alexander Meyerhofer for his support, and Moritz for your nice live demo. Thank you very much.